I want you to do another test. Go to the Weka and to look at the example of the diabetes. And when you run the diabetes by the 3 algorithms you learned so far, one is decision tree, is J48, one is naive Bayesian, and the one is now Bayesian network. Tell me next time, if you can, which one's better, and which one's the best by your understanding of the confused matrix and the F-score, and run it. It's interesting. Okay. Any questions, Sean? Alex? No. Okay. So the homework is postponed to Friday. Tell your buddy, give me the homework on Friday if you can. That's the homework. And also, I'm going to push myself grading all the homework to give you back on Friday. I get the hectic time this period. Just have always those unplanned things. Anyway. Okay, what's the characteristic of the Bayesian network? First, it really capturing the prior knowledge of a particular domain. That's very important for scientific research and medical research, when the data is not this random, basically, those things. And they have a causal relationship clear. So that's the strengths. And once you build this network, it's very difficult to build because the permutation is too much. But once you add one more attribute, that's easy. Because one attribute maybe add a few links. So it's an incremental. Once you build it, it's not hard to add one. So what's good is very good to deal with the incomplete data. Because the relationship is there, the missing attribute, you can do the interpolation, together, or average, or median, whatever you do. And also, each single data estimate, when you do the interpolation, it won't affect the probability of your estimate because you build it based on the existing case, right? So that's a very good thing. Especially medical data, you get a lot of incomplete data because you get somebody that don't have all the diseases. We call it, this is called spice data or spice information matrix. That's the hottest research now. Because in the real field, you don't get a complete set of data, everything you need. You're talking about the patients. They have a lot of attributes and a lot of disease, a lot of symptoms. The only problem is a lot of symptoms they don't have. They don't have the disease. And then you get a lot of zero or say false. And those data is the frontier of research in the data science. And then they are very good for incomplete data, and they are also robust for overfitting. Why is robust for overfitting? Because they're based on the statistics, and the tree won't go on and on with little branches if you have only a few cases, because you already pretty much built the tree in that case. So what's bad? Well, the bad is the complication. The complexity is way bigger than even the decision tree is complicated. That's way more complicated than decision tree, because each time when you build another branch, if they're correlated, you need to build this conditional probability. On the left hand is the condition with all the combination. Hope you have the binary, otherwise the combination itself is tremendous, right? And then on the right hand, you need to look at the probability of this. That will not be easy for huge, like the natural language processing. You have so many attributes for the keywords, for those names, let's say the terrace names. and those groups. When you get this, that's just naive Bayesian. It's good enough. And there's other models sounds very good, but in practice it's bad because it really depends. Just like the example I give to you, which just ask a simple question. Once you ask enough people, because everything is kind of random on their memory, but there's only one truth. This truth will kind of accumulate to make it work. That's how the power of data mining really comes from the big data. And sometimes a simple rule wins. A lot of times. That's why you want to do the experiment. And the last time you remember the weather example, I think it's one simple rule win, right?
Mm-hmm.
Yeah, it is. Yeah, the rain and okay, that's for today, and then we're going to move on to the artificial neural network, the perceptive method. This one is I will call it get a second life because the Google. Yeah, it's for the longest time. I think Dr. Eric Hill used to do that, teach this neural network. It used to be almost equivalent to artificial intelligence, and it's still very hard. But because the computational power at that time, the algorithm is not that good, so they are very limited and made you cannot say made this point. It's just because overclaimed in the beginning and did not get as much. But if we talk about any intelligent machine, they have some of those inside the building. So it's a must-know technology. It's a neural network. We call it artificial neural network. Just like simulate our brain, how it works.